Alright, so is this thing on? Alright. So basically, I'm not really liking the way she's teaching this in class, so I'm just going to make a video about it and hopefully you understand. So this is going to have some processing basics and basically this pre-lab, so hopefully you learn something from it. Alright, so basically the premise of this pre-lab is to understand loops in processing and in other programming languages as well, I guess. So the first problem is to make these ellipses on the screen using a while loop. And what I'm going to do is I'm going to actually start with void setup. We'll just start with void setup all the time. Basically, anytime you open processing, you always want to start with a void setup. It's even in the name, setup. So what I'll do here is I'll define the size of the screen. By default, I'll always use 400 by 400 because I'm just used to that. It's what I've been doing. So I'll just keep doing that. And what I also want to do is, actually let's just leave it at that for now. I'll just tell you what my train of thought is. So we have void setup 400 by 400, and then after void setup always comes a void draw. Actually not always, but most of the time. So this time we'll do void draw. And what we want is a while loop, drawing these ellipses. So void setup only runs once, void draw runs repeatedly, every single tick. So actually what we'll do is in void setup, we will put the frame rate function, which tells how many times per second you want void draw to run. So frame rate 5, which is 5 frames per second, void draw will loop 5 times every second. So that's just in the later problem, so I'll just go ahead and put that right now. And what we want to do is create a while loop. So we'll say while, and we need a variable. So what I'll do is I'll go up here and just create a variable for the while loop. I'll just call it W for now. Nothing's significant. And we'll make it height divided by 3. And this is going to be the counter, and it's going to be the center of these circles. So it's going to serve two functions here, two purposes, I should say. It's going to be a counter to see how long the while loop lasts, and it's also going to be the center of each circle. So we're going to have while W is less than the height. So since W is going to be the center of the circle, once W crosses outside the boundary of the window, we want the loop to terminate. So while W is less than the height, we're going to put an ellipse with width divided by 2. And since all of these ellipses are in the center of the screen, it's constant, right? The x coordinate is constant. Remember what argument ellipse takes in. It takes x, and then y, and then the size of the ellipse in the x direction and the size in the y direction. So for the x coordinate of the center of the ellipse, actually we should do that as well right now. Ellipse mode center, because by default ellipse mode is actually corner, and we don't want that right now because corner is kind of trickier to deal with. So now that we have ellipse mode center, the x and y coordinate of this ellipse function defines the center of the ellipse. All right, we'll do width divided by 2. And then we'll do W, because the y coordinate of the ellipse is actually the one that's changing as the loop progresses. So we'll put a W, and then the size is also constant, which is width divided by 6. Misspelled it. Gosh. And height divided by 6, which is what's defined in the problem. All right, and every time this iteration runs, we want W to equal, or this single equal sign basically signifies get. So W gets W plus height divided by 6. So basically what happens with this is that every time an ellipse is printed, every time a loop runs, W becomes what it was before plus height divided by 6. So W goes up by height divided by 6. And actually there's a shortcut for this. Instead of typing all of this out, we can say W plus equals height divided by 6. And this is exactly the same thing, but it's just shorter. So I'll be using this from now on. Okay, So now that w plus equals height divided by 6, it'll keep increasing by height divided by 6 until w is greater than the height. So this is exactly what we want. Let's play the thing and see if it works. All right, so yeah, that's what happens. So it starts here, and then it goes up by height divided by 6, and height divided by 6, height divided by 6, and every time it's checking if w is greater than the height, or it's actually checking if w is less than the height, and this is true, so it keeps going up, and then after this iteration, w becomes greater than the height, so the loop terminates, and that's exactly what we want. So yeah, that's the first problem down. And I'll just comment this out so we can move on to the second problem. All right, let's start again. This time we're trying to do the exact same thing, but with a for loop. And let's do that. So let's start with for. This is how a for loop starts. So the syntax of a for loop is always for, and then you want to define a variable within the for loop. So int I, which is what most people use in a for loop. So we'll say for int I gets height divided by 12. So this is going to be the center position of once again, this variable I is going to serve as a counter plus a check in the loop. So we'll say int I equals height divided by 12, or I should say gets. I keep saying equals, that's just what I'm used to, but I should say gets because it's actually doing something. So int I becomes or gets height divided by 12. And then the next phrase in the for loop is the check. So I is less than height. So we're checking if I is less than height. And then the last phrase in the for loop is what you want to do with the counter variable. So I plus equals, which remember it just means I equals what I was previously plus height divided by 6. So you see this is actually pretty similar to this, the while loop. It's pretty much the same exact thing, except everything is in one line, which is quite convenient. So there's that, and then it's pretty much just going to be the same thing. Ellipse, width divided by 2, I, width divided by 6, height divided by 6. Whoops, that's supposed to be a semicolon. And let's see if this works. Yep, exactly the same thing, except we use a for loop instead of a while loop. I equals height divided by 12, so it starts here. And then it checks if I is less than the height. And it is. So it'll run the loop, and then after the loop iterates once, it'll increase I by height divided by 6. And height divided by 6, if you guys didn't realize, is actually exactly the diameter of the ellipse. So it'll increase, and then increase again by height divided by 6, height divided by 6, height divided by 6. And then finally, I is actually greater than height, so the loop terminates. So this is exactly the same, except we've used a for loop. So let's comment that out and move on to the next one. And this next one is a little trickier, but not too much. We're going to be drawing squares across the screen, diagonally up and diagonally down. So almost like a checkerboard, but not really. So let's do that. Void draw. Oops, that's the wrong type of bracket. All right, and then let's just use a for loop. For loops and while loops practically do the same thing, but I prefer using a for loop because everything stays in one line rather than having to define another variable outside the loop. And all right, so for, I'm just going to use a different variable this time. Int j equals 0, and then j is less than the width, and j plus equals width divided by 10. All right, so once again, this j variable is going to serve as the counter for the loop and as the coordinates for the squares, so we can be efficient with our code. So naturally this thing is going to run 10 times, because every time it increases by width divided by 10. You could basically just replace width with any number you want. So we could say it's 10. So j is less than 10, and then j plus equals 1. And it's the same thing, except instead of hard coding with variables like that, with constants like that, I mean, we have a variable here width, which does exactly the same thing. But it's great because even if you change the size, this thing will still work. So fill, we want to fill it with something, I guess. And we're going to just do random, because I think that's what the problem is requiring here. 0 to 256. Remember that random can only go up to 255. Or, I mean, the colors, they only go up to from 0 to 255. I'm just going to copy and paste it. But the random function actually goes up to the highest number listed in this argument, not including the number. So random actually returns a float. So the random function between 0 and 56, once this number runs, it'll actually return a decimal number. But that doesn't matter, as fill can input floats as well. So the function for fill can actually take in decimal numbers, which is why this function works. Otherwise, you would have to do int here, which would access the random function, and then it would turn it into an int. So instead of leaving random as a float, it would turn it into an int. But we don't really need to do that here, so we'll get rid of that. And the next line would be rect, which is the rectangle function. And then it's going to be j, which is the x-coordinate, j, which is the y-coordinate, because it's going to go down across the screen. And then the size of the rectangle is actually going to be constant. It's going to be width divided by 10, height divided by 10. So let's just run this for now and see what happens. All right, so that's exactly what we want. So rectangle, by default, its mode is corner. So remember how we set ellipse mode to center? That's actually the default for ellipse as well. We have to change that. But rectangle, by default, is in corner. So this is actually convenient for us here, because it actually moves down the screen like this. So it's actually more convenient to leave it in corner. So I didn't change the rect mode to anything. So rect jj here. So j equals 0 at first. So it makes a rectangle at 0, 0. So it starts in the top left corner here and makes a square, because the x and y size is the same. So it goes width divided by 10, height divided by 10. And it makes 10 of them, because of our loop. Our loop runs 10 times. And the size of the rectangle is just big enough to fit 10 of them on the screen. And the reason it's changing color like this is because, remember, draw runs 5 times per second now because of the frame rate function. Frame rate is set to 5. So every 5 seconds, it's filling the rectangles with a random color. So that's that. And then we got to make rectangles go across the other way as well. So actually, we can do that in the same loop, and I'll show you how. So rect j. Okay, so this is the x-coordinate. X-coordinate's going to be the same, so we don't have to change that at all. What we need to change is the y-coordinate. So the y-coordinate is actually going to be height minus j. So height minus j. So what it's going to be right now is going to be height minus j, which is 0. So it's basically going to be at the height every time, and then every time the loop runs, it's going to keep subtracting another one. So it's basically going to be the opposite of what we have of the first rect function there. So, and then the size is going to be the same. So it's width divided by 10, height divided by 10, and then let's run it and see what happens. But oh no, look, it's actually off the screen. So this is actually wrong. The reason this is wrong is because if you do height minus j, what happens, the first rectangle becomes height, right? And then it subtracts j. But j is 0, so it's actually going to make a rectangle right at the corner, and then it's going to go down. So this first rectangle is actually off the screen. So we're gonna have to fix that. What we want to do, pretty simple, is just subtract another width divided by 10. And let's play this and see what happens. And yeah, it's exactly this. It's exactly what we're looking for. So height minus j, which is 0, and then it subtracts another width divided by 10, which is basically the size of one square. So it makes a square right in the corner, and then it goes up because j increases, and height minus j, which is width divided by 10, minus another width divided by 10. So it goes up, and it places a square there, across, and then all the way up. And that's that. If you want to make that a different color, all you have to do is make this fill function again, and this time there'll be different colors. All right, and yeah, that's it. Yeah, hopefully you learned something.